All right, ladies and gentlemen, part of what I would normally do in the classroom is go through these rate law practice problems with you. So I'm going to go through those with you now. There's one in the notes that the notes go through, and I want you to look at that and try to figure that one out. And then kind of follow along with this one as well to help you do the practice part of the notes. So the first question is, what is what order is the reaction with respect to A? Now, when I'm looking at reaction rates with respect to A, I have to make sure that the concentration of B is being held constant. So that way, the only thing that's affecting the reaction rate is the concentration of A. So B is being held constant in experiments 1 and 2. So we're going to take a look at the data from experiments 1 and 2. And when we do this, we take the concentration. It's easier if you do the higher concentration divided by the lower concentration. So we're going to take the concentration of A in experiment 2 divided by the concentration of A in experiment 1 to some power. That's going to be our order of reaction there. That's going to equal the two rates divided. So 5.0 times 10 to the negative 2 divided by 2.50 times 10 to the negative 2. 1 divided by 0.5 is 2.0 to the x power. 5 times 10 negative 2 divided by 2.5 times 10 negative 2 is also equal to 2.00. Our x power then is going to be first order with respect to A. 2 to the first power is equal to 2. So that is first order with respect to A. Now, in order to do B, we have to make sure that A's concentration is constant. It is constant in experiment 1 and 3. So in order to figure out B's difference, we have to look at experiments 1 and 3. So we're going to take the concentration of B for experiment 3, 2.0, divided by the concentration of experiment 1, 0.50, and that's going to be to some power. And then we divide those two rates. 2.50 times 10 to the negative 2, 2.50 times 10 to the negative 2. 2.0 divided by 0.50 is 4.0. That's going to be to some x power. 2.5 divided by 2.5 there is equal to 1. X then must be 0 power. It is going to be 0 order with respect to B. Anything to the 0 power is always equal to 1. When we write the rate law then for this expression, rate is going to equal K times A to the power of 1. We are not going to include B because B is a 0 order and it has no effect on the overall rate law expression. So anything that's a 0 order you do not include in your rate law expression. Now we're going to calculate the specific rate constant for the reaction. The specific rate constant here is K. So I'm going to rearrange the equation to solve for K. To do that, I need to divide by A to the first power. So K is going to equal rate divided by A to the first power. It doesn't necessarily matter which data you use. I always choose experiment 1 or trial 1 just to stay consistent. So if we look at trial 1 data, the rate there is 2.50 times 10 to the negative 2 molar per second divided by the concentration of A, which is 0.50 molar. Now calculating that, we get 0.050. We also have to calculate the unit of K. So what we do is we take a molar per second divided by molarity. And when you take a fraction and divide by something else, it's the same as multiplying by the reciprocal. So it would end up looking like that instead. So molar per second times 1 over molar, the molarity cancels, and your unit you're left with is a 1 over a second. The overall rate order for the reaction, you add up your exponents. And my exponent here is only a 1. That's all I have for the first one. So my overall rate order for this reaction is 1. Okay, now we're going to look at the second problem here and figure out the rate law expression for this one as well. So the first part of the question, what order is the reaction with respect to A? We have to look at A when B is constant. B is constant during experiments 1 and 2. So we can look at data A. That means the rate is changing based on the changes in A. So we're going to take the bigger number divided by the smaller number again, 0.75 divided by 0.25. That's going to be to some x power. And then we divide our two rates there. 5.40 times 10 to the negative fourth divided by 1.80 times 10 to the negative fourth. 0.75 divided by 0.25 is 3.0 to the x power. And that's going to equal 5.40 divided by 1.80, which is also 3.00. That means that x is equal to 1. A is first order then for the reaction. Looking at B, we have to make sure that A is held constant. It is constant for experiments 2 and 3. So we're going to compare B data for 2 and 3. Again, we're going to take the bigger number divided by the smaller number. So 0.50 divided by 0.25 to some x power. That's going to equal 21.60 times 10 to the negative fourth divided by 5.40 times 10 to the negative fourth. 0.50 divided by 0.25 is 2.0 to the x power. 21.6 divided by 5.40 is 4.00. So x then is 2. 2 to the second power is equal to 4. So the order of the reaction with respect to B is 2. So writing our rate law expression, rate equals K. That's how rate law expressions always start off. A was to the first order, and B is to the second order. So the rate law expression would look like that. Solving for the specific rate constant, I am going to be solving for K here. So rearranging the equation, getting K by itself, I need to divide by A to the first and B to the second power. So K is going to equal rate divided by A to the first power times B to the second power. I'm going to use experiment 1 data again and plug in for those values. So that is going to be 1.80 times 10 to the negative fourth molar per second divided by A to the first power, which is 0.25 molar, times B to the second power, which is 0.25 molar, and that would be squared there. So really what I end up having here is 0.25 squared times 0.25, which is 0.25 to the third power. So 1.80 times 10 negative fourth divided by 0.25 cubed comes out to be, with 2 sig figs, 0.012. Now in figuring out our unit for our specific rate constant here, what we end up having is a molar per second divided by molar squared and molar, which is m cubed. Again, whenever you have a fraction, you're going to want to multiply by the reciprocal. So we have m over s times 1 over m cubed. One of the m's cancel, and that becomes m squared. So we end up with a 1 over s times m squared for our unit there. The units tend to be one of the hardest parts of this reaction. The overall rate order for the reaction, you add the exponents of your orders. 1 plus 2 gives me an overall rate order of 3.